3-2 in college algebra, a lot of solving quadratics. Last class period, we talked about all these methods. The square root method, you can only use that when there's no x to the first. And then factoring, all kinds of factoring. Completing the square works when things are not factorable. And obviously, we can always use the quadratic formula. And then later, when things get hairy, we'll use our graphing calculator to solve. If it doesn't tell you on any of these problems how to solve the quadratic, quite honestly, it's your choice. Sometimes they could factor, sometimes you can complete the square. Quadratic formula always works, it's up to you. But let's check this guy out. X squared minus 3x minus 10 equals 0. I can eliminate him. Square root method, I cannot use him because aren't there x to the first and x to the second in the same equation? He is in standard form where it's equal to 0. I want to check, since the a value is 1, to see if it's easily factorable. Can I find two numbers that multiply together to be a negative 10 and add together to be a negative 3? How about 2 and negative 5? Would you agree? So since this is easily factorable, you don't need to go through all that work. You just put it into two quantities. X plus 2, because the 2 was a positive number, times x minus 5, since the 5 was a negative number. And don't forget, it's still equal to 0. If I go too fast for you, you let me know. Okay? Got to keep it equal to 0, folks, because you've got to solve an equation. Then x equals negative 2 or positive 5. Right? Because what makes this 0? Negative 2. What makes him 0? Positive 5. Then we put them in solution sets. So things that I grade tough on is, number 1, did you keep it in an equation the whole time? Number 2, did you actually solve it, like what x equals? And then did you put them in a solution set? Cool? Let's scroll over to number 2. He again looks like a candidate to see if he's easily factorable because the a value is 1. So let's see if we can find two numbers that multiply together to be 24 and add together to be negative 11. Tell me about the two numbers. Both positive, both negative, or one negative. They both have to be the same sign since they multiply together to be a positive number, right? So, and since that's negative, they're both negative. So multiples of 24, negative 1 and negative 24, but they don't work. Negative 2 and negative 12, those don't add to negative 11. Negative 3 and negative 8, there's our bingo right there. Okay? And I'm doing all the hard work for you on the first two problems. The hardest part about factoring is finding the two numbers. Keep it an equation. Solve x equals 3 or 8. And then solution set. Awesome. Next one. First, he's not equal to 0. Get him equal to 0. So I'll subtract 4 from both sides. Awesome. Then I notice he's not easily factorable. Tell me why. Why is he not easily factorable? A isn't 1. I also notice this. 6, 10, 4. Isn't there a GCF of 2 that goes into each one? Yes. GCF. Let's take him out. What's the GCF? 2. So if I take him out, is that all good in the neighborhood? And then, back in Algebra 2, we didn't show you this because we wanted you to realize what that GCF needs to keep coming along for the ride. But see if this is legal. Maybe. I would divide that by 2 and divide that by 2. Can I do that? Can I divide both sides by 2? Yes or no? Is it legal to take an equation and divide both sides by 2? What happens here? Those go away. What's 0 divided by 2? 0. So you can just kind of say, oh, I took out my GCF, and now he's gone. When you're trying to solve, and the other side was a 0, right, you just divide both sides by whatever that GCF was, and, well, there we go. Now, he's still not easily factorable, but I'm dealing with much smaller numbers, so let's see if I can frowny face him. Find me two numbers that multiply together to be negative 6 and add together to be a positive 5. 6 and negative 1 is what I heard. We agree? So then we split this guy into 4 terms. The first term is whoever that guy was originally. It makes no order what you put these two in. If one of them is negative, it is to our advantage to put the negative 1 first and the positive 1 second. Don't forget you need your variable with them also. and minus 2 equals 0. What you do then is you double group. First two terms into a group, last two terms into a group. Pick out a GCF in each group. In the first group, x is the GCF. I better get a 3x minus 1 for my common group. So if I take out a GCF of 2, I will get that 3x minus 1. Again. Final move, regroup x plus 2 times the common group, because the GCFs became a group of their own, still equal to 0. Then to solve, negative 2 makes this brother 0. And then the trick again, when you have this mess in here, is take the opposite of your second term, which would be a positive 1, and put it over that number of 3. Then we can stop doing the solution set if you want to save a little time, because we're kind of behind today. But realize you put them in a solution set. Awesome. Number 4, you should let y equal 0. And can't do the square root method. Can't do easily factorable. Let's try Founty face. These multiply together to be a positive 12. Why don't you factor that for me? Please pause the video and get that done. Here's the goofy part about this. I found the two numbers when they're both negative. So, I'm sorry, I should double group. My bad. When this guy's negative, you got to take out a negative GCF. So I throw a little plus in there, and let me erase this. Whatever your first dude's sign is, here's my first dude, here's my first dude, whatever his sign is, that's the type of GCF you have to factor out. So here I'd factor out an x, and it was positive because my first dude was positive. Here, since that guy's a negative, I have to factor out a negative GCF. 6 and 4 have a 2 that go into them. X does not go into each one. And if I take negative 6x divided by negative 2, that's where I get my positive 3x. And positive 4 divided by negative 2 is my negative 2 right there. Then, whoops, I'm all over the place. I would double group, regroup, and solve. X equals positive 2, or what's the solution popping out of this guy right here? Positive 2/3. It's the opposite of this guy, which is a 2, over that guy. These were all factorable. Number 5. I got to get them equal to 0. And there is no way in the world that I want to try to factor this. It is not easily factorable because a is not 1. I can't take out a GCF of 3 because 3 doesn't go into 1,000 evenly. So way too big of numbers, man. It's time for quadratic formula. So let's do the quadratic formula. A is 3, B is negative 130, and C is 1,000. This is where the quadratic formula pays dividends when you have large, large, large numbers. So the opposite of B, plus or minus, B squared. What's negative 130 squared? Help me out, please. I don't have my calculator open. Should it be positive or negative? Positive. What'd you get? 16,900? I should have known that. 169 with 2 zeros, right? Minus 4 times A times C. I'm a big fan of writing all this stuff out. All I've done so far is what B squared was, all over 2 times A. Now let's slow down and talk for a second because this has to do with our backside. The backside of this problem. This thing right here, the number underneath the radical, is called the discriminant. If the discriminant is a positive number, we are in good shape because don't we have to square root this number, correct? So you will get 2 solutions if the discriminant is a positive number. If the discriminant is 0, you will only get 1 solution to this. And if the discriminant is a negative number, you will get no real solution. So please just type this green stuff in from left to right. What's 16,900 minus 4 times 3 times 1,000 while I open my calculator. That comes out to be 4,900. Is that correct? Let's see if that's a perfect square. I'll bet you that it is. Take the square root of 4,900. Is that a perfect square? Did you get 70 for that? Nice. What that means if the discriminant is a perfect square, that this was factorable in the first place. But no way in the world would I really want to factor that. It's too large a number, but it could have been done. So now I do two situations. 130 plus 70 is 200 divided by 6. 200 divided by 6. Math enter. Be 100 thirds. 130 minus 70, that's 60, correct? 60 divided by 6 is 10. So 100 thirds or 10. If you put 33 and 1/3, I'd be cool with that also. It's up to you. It's 33.3 repeating. You know, what we're finding here is where this parabola crosses the x-axis at. These are the x-intercepts of the parabola. 6. How many terms are in that puppy? Forgetting about the equal 0. 2 terms. 2 terms. There's only one shortcut that you know of when there are 2 terms, is if this is a difference of squares. Is 4x squared a perfect square? Is 9 a perfect square? And you are subtracting them. How do they factor? Well, that's your memory. They factor into conjugates of the square roots. Square root of 4x squared is 2x. Square root of 9 is 3. Same quantities each time except for the sign, and it's still equal to 0. Now I can use the zero product property to realize x equals negative 3/2 or x equals positive 3/2. You'll get the same answers with different signs. You get opposite answers when it's a difference of squares. 7. Check these out. Which method would you use? Square root method, factoring, completing the square, quadratic formula, or use your graphing calculator? There are x squareds, right? So it is quadratic. What don't you see in this problem? I see x squareds. What don't you see? X to the firsts. If there's no x to the firsts, you should use the square root method. People are like, I don't know what that is. What's the square root method? Get x squared all by itself on one side of the equal sign. What would you have to do to get x squared all by itself? Add 20 to both sides. Cool? And if x squared equals 20, you are totally cool to square root both sides. X equals plus or minus the square root of 20, which then will simplify the radical. Split it up into 2 guys. The biggest perfect square that goes into 20 evenly is a 4. And how many times does he go in there? 5. The reason why we did that is because we know what the square root of 4 is. The square root of 4 is 2. So x equals plus or minus 2 square roots of 5. Cool? Number 8, why can't I use the square root method? What we just did, why can't I use the square root method? It's got x to the first and x squared in the same equation. Looks like it could be easily factorable. Let's find 2 numbers that multiply together to be negative 9 and add together to be negative 4. One number has to be negative. 1 and 9 or 1 and negative 9. No good. 3 and 3, and one of them has to be negative. No good. It doesn't factor. So factoring is out. Now to complete the square or quadratic formula, it doesn't matter to me what you use. I would complete the square because it's A1 and is B even, yes or no? So I'm going to complete the square. The way you do that, set it up with blanks and get all your x's on one side and all your constants on the other side. If you don't remember how to do that, because I know a lot of you weren't taught that in your Algebra 1 class, use the quadratic formula. It'll get you the same answers that we're going to get right here. Okay? How do you fill in the blank? Take half the b value and square it. What's half our b value? Negative 2 squared, which is 4. That goes in each blank. The reason why we just did this is because this is now a perfect square trinomial. It factors very simply into the square root of this guy and the square root of this guy. And whatever sign you are right here in the middle, he comes down, and that quantity gets squared. That's a perfect square trinomial. Over here, 13. So far, so good. Since this is a quantity squared all by itself on one side of the equal sign, it's like you can square root both sides. And those cancel. You're left with x minus 2 equals plus or minus the square root of 13. 13 is not a perfect square, nor does it simplify. And all you do now to get x all by itself is add 2 to both sides. And you can't add radicals and whole numbers together, so you just get, like, they're not like terms, if you will. So you get 2 plus or minus the square root of 13. If you would have done the quadratic formula, you'd get the same thing, but you would have had to reduce that answer because you would have had a denominator and like a number goes into all of it, and it's just more work to do the quadratic formula if you're not familiar with completing the square. 9. Is there a GCF I can take out of that bad boy? Nope. 16. Two numbers that multiply together be 16, add together be negative 9. See if you can find them for me. I know they both have to be negative numbers because they have to add together to be negative. Negative 2 and negative 8 doesn't work. Negative 4 and negative 4 doesn't add together to be negative 9. Isn't that it? All right? So I cannot factor it. And no way do I want to complete the square because A is not 1 and B is not even. So what's our last option? Quadratic formula. Opposite of b, plus or minus b squared minus 4ac. Make sure it's equal to 0 first before you're going, which this was, all over 2 times a. Figure out your discriminant next just by punching all of that stuff in from left to right. 81 minus 4 times 2 times 8. 81 minus 4 times 2 times 8. 17, is that what y'all are getting? Cool. That's good because you should not get a perfect square. We've already figured out that it wasn't factorable. If you get a perfect square underneath there, then you could have factored it. So it's whatever. We'll still solve it. And then that's it, right? Nothing reduces. You look at these 3 numbers. I'll put that 1 right there. You look at these 3 numbers. I call them the triangle of death. If there is a common factor between those 3 numbers, you can reduce this. Awesome. Next one. 3, 6, 12. What do you see we can do first? GCF. What's the GCF we'd take out? And check this out. Then you divide both sides by 3 anyway. Just do this right away. Let's divide everything by 3. Both sides. This will turn out to be 1x squared minus 2x minus 4 equals 0. Correct? See if we can factor this. Since the a value is 1 now, let's see if it's easily factorable. Numbers that multiply together to be negative 4 is 1 and 4, but one of them has to be negative. But those don't add up to be the correct numbers. Or 2 and negative 2, those don't add up to be the correct numbers. I cannot factor him. Complete the square or quadratic formula. It's your choice. I think complete the square is pretty easy because a is 1 and b is even. If you don't like it, use quadratic formula. Let's complete the square just for more practice, though. Set it up with blanks. You got all your x junk on the left side, all your constants on the right side. Don't forget you have to move him over by doing the opposite operation. Half your b value squared. So negative 1 squared is 1. Goes in each blank. Now factor this perfect square trinomial. That's the part that people kind of are like, okay, now what do I do? Square root of the first guy, square root of the last guy, and the sine of the middle guy. Quantity squared equals 5. Then square root both sides. Then add 1 to both sides. And if you'd have done the quadratic formula, you would have gotten this, but it would have looked more like this. You would have had some multiple in here. It probably would have been 2 plus 2 square roots of 5 over 2. You see, you'd have to reduce everything by a factor of 2, you know. So it would have been something in that ballpark. Yay! 12. Excuse me, not 12, but 11. Let's figure out what method we'd do and then just move on from there. Okay? We've got a lot of these. It seems like you kind of get what's going on. So, first of all, is he in standard form? Yes or no? Put him in standard form. Then your two options at this point, since there's no GCF, is either frowning face factor or quadratic formula. If you have a hard time finding the two numbers, you know, it depends because they always want exact solutions. Negative 24. Can I find two numbers that multiply together to be negative 24 and add together to be positive 5? Yes or no? Can that happen? 8 and negative 3? So I would choose frowning face factor on this. If you didn't do that, what's your other option you could have chose? Quadratic formula. Okay, now let's skip it. Let's go to number 12. What's the method, baby? Hopefully you have that sheet from last time with all those methods up there. What's the method that you... Yes, you can use the quadratic formula on here, but you must realize that b is 0, right? But what's the easiest way to get this puppy done? Square root method. This one I want to do. Square root method, we haven't done a lot of them. Okay? You got to get x squared all by itself. Oh no. I will subtract 25 from both sides. Right now, you should be entering the world of imagination land. Because don't you have something squared turning out negative? No big whoop. We'll square root both sides. X equals plus or minus. When you take the negative 1 out, doesn't that turn into an I situation? And is 25 by itself a perfect square, yes or no? So you will get 5i, right? The 5 can come first, then the I will come second. Don't write I5. If it wasn't, like let's say you had this, square root of negative 13, then you call that I square root of 13, right? The I comes out and the square root of 13 does not simplify. But square root of negative 49, since 49 is a perfect square, you'll get a 7, and the I goes second. Okay? And 13, that is also a square root method. Why is it a square root method? Because it is something as a quantity being squared all by itself on one side of the equal sign. So let's square root both sides. This turns out to be x minus 1. And what's the square root of negative 4? Don't forget the plus or minus, right? And what do you get? 2i, right? Because it's negative underneath there, you'll get the I coming out. 4 was a perfect square, and x equals 1 plus or minus 2i. Yeah? Backside. There's our discriminant information again real quick. If you have a positive discriminant, a parabola will cross the x-axis in 2 places. This isn't on your sheet, just showing you stuff. If the discriminant is 0, the parabola only crosses the x-axis at one place, at the vertex. And if you have a negative discriminant, that parabola never crossed the x-axis at all because it got shifted up or shifted down. So, consider the graph below, which you have. Is the discriminant positive, negative, or 0? It's all about how many places he crosses the x-axis. Doesn't he cross 2 places? So what kind of discriminant do we have? Positive. My bad, that goes up here. So he was positive. How many real solutions will there be then? Well, you could see them. How many real solutions are there? There are 2 real solutions. Solve the equation. Okay, I can tell you what x equals. X equals, what's the x value right there? Well, that puppy crossed the x-axis. Negative 2. Or the solutions are where the puppy crosses the x-axis at. So my math lab should ask you stuff like that. Those will be the simple questions. Let's make a sketch of this graph right here. So the height above ground of a ball thrown up, 64 feet per second, gives us this formula. Let's put him in our graphing calculator and make a nice, neat sketch of him. That's not what I wanted to do. So we get him in our graphing calculator. Let me tell you some basics. This is your y-intercept right here. 80 is your y-intercept. This parabola is going to open down, but it's a ball thrown. So since my y-intercept is 80, that's how high the ball is when it starts. And it's like, where's it going to be when it finishes? Let's change our window. Let's go. First, let me zoom 6 real quick. Get all that nasty stuff out of there. Now let's change our window. X minimum, you can just leave them at negative 10 if you want to. The X maximum, let's leave them at 10 also. It shouldn't take more than 10 seconds for a ball to hit the ground. Right? You throw a ball, 10 seconds is a long time. So let's see what that is. It's your Y max. you've got to go above 80, because doesn't it start at 80 feet high? So let's go up to 200 and just see what that looks like. Scale, I'll go by, I don't know, 20s. I don't know, just seeing. Oops, I didn't change my X-min. So this is, did I type it in right? 80 minus, oh, it's got to be plus 64x. That shouldn't be right. There we go. All right, so here's my sketch. Nah. I'm going to take not dashed information, go. You could use an actual ruler on top of your tablet if you had a ruler out. You can use the line tools if you want to, which take way too much time in my opinion. Like I would hand out straight edges if we were doing a lot of stuff and actually have you use a straight edge, but this is just a sketch. It said accurate though, so here's what I'll do for right now. And then I'm going to, these questions that we answer, I'm going to go back and put them in the sketch as we answer them. It says, how long will the ball be in the air? Well, check it out. Didn't it go from here? It's in the air, 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 in the air. No longer in the air because it hit the ground right there, correct? Let's figure out where it hit the ground right there. That is an x-intercept, right? It's a root or a 0. So if we go to second calculate, it's been a while. If you find your x-intercepts, that is option 2 on your graphing calculator. And then you have to do the left bound and the right bound. What that means is please move your cursor somewhere to the left of that x-intercept. So the x-intercept is right where my arrow is. This is to the left of it, to the right of it. Come down a ways, guess, and it'll tell me at 5, 0. So I'm going to put that on my sketch. That's why it's called an accurate sketch, 5, 0. How long was it in the air then? What does that mean to us? 5, go back, read label, seconds. So far, so good. When was the ball 128 feet off the ground? Is 128 an x value or a y value? It's a y value, correct? Well, the way we taught you a long time ago was put 128 in for y and solve for x. We'd have to use quadratic formula. We have a graphing calculator. Go back to y equals. We have this graph up here. Don't we also want to know when y equals 128? Is that the right number? 128. So type in y equals 128, and it will graph a horizontal line at 128, and it will show you how many places this ball was 128 feet off the ground. Didn't it happen twice? It happened here, and it happened here. What will I need to calculate to figure this out? Intersection. So let's do this to save time. You front row boys right here, please calculate this intersection place. And the rest of you, please calculate this intersection place. How do you do it again? Second calculate, option 5. They're asking you to select the curves. So it says first curve, just hit enter. Second curve, just hit enter. And then move your cursor to whichever one you want to try to find, whichever it's closer. So the guy on the left was at 128, and I'm going to actually sketch that on my deal right now. This is y equals 128. And here's that place. It was at 128. This is our accurate sketch. And where did you guys get the other one at? 3, 128? Agree with that? So it says, when will the ball be 128 feet off the ground? We need the x values. Those are our seconds. So when did it happen? At 1 second and 3 seconds. How come it happened twice? Because what happened here? Wasn't the ball still going up at that point? It started 80 feet high, went up, got here, kept going up, came back down. It reached 128 feet high again on the way down. When will the ball be at 1.5 seconds? Are we okay? When is that 1.5 seconds? Go to second calculate. If they give you an x value, all you have to do is choose option 1, value, and type in 1.5, and it'll tell you at 140 feet. You also could have just hit trace 1.5, and it'll do the same thing for you, right? If you just hit the trace button and hit 1.5. So 140 seconds. Don't need to put that on the graph. What's the maximum height of the ball? Calculate the maximum. Left bound. Right bound. Yes. At 144. Don't forget, some calculators can't be accurate enough, so that's really at 145. So that's 144. It was 144 feet. And when did it occur? 2 seconds. Yeah? Oh, awesome. Last one. Total revenue for French door refrigerators is given by this. R is revenue. That's how much money you make, right? How much they make. The cost is how much they spend. Here's the equation for that. They say for both functions, input X is the number of refrigerators produced and sold. Form a profit function. How do you make profit? If revenue is how much you make and cost is how much you spend, your profit is what? How does profit relate to the money that comes in versus the money that you spend? Like, watch this. Let's say I made $100 revenue and I spent 20 bucks. What's my profit? $80. How did you get that? Profit equals what? I made 100 and spent 20. How did you get 80? Revenue minus cost. These type of problems aren't going away. This profit, revenue, cost. They're trying to introduce that to you because it's new to you, right? Profit is the money you make, which is called revenue, minus your cost. So wouldn't profit equal revenue is 550x? Everyone cool with revenue being 550x? Then I got to subtract away the entire cost function, so I need to make that a quantity because I'm subtracting the whole thing. And that means you really should distribute this negative through. So you've got your profit is 550x minus 10,000 minus 30x minus x squared. Then you can combine your like terms and put it in standard form at the same time if you want to. You have negative x squared, done with him. 550x minus 30x, isn't that a positive 520x? Am I right about that? And then you have negative 10,000. That's all they wanted for part A. Cool? Part B, what is the profit? Profit means please use your profit function. Isn't this our profit function? If 18 refrigerators are sold. 18 is refrigerators. Isn't that x? So please put 18 in for x in parentheses. All right, just put 18 in there. So you got negative 18 squared plus 520. I'll let you punch it. I'm just showing you what to punch. What did you get? Go ahead and tell me. It might seem to freak you out, but what did you get? Negative 964. Is that what you're getting? People are like, hey, man, it's a negative number. How can that happen? You can totally have a negative profit. They call it something else when you have a negative profit. What do they call that? That's a loss. It's a loss of $964. Don't say a loss of negative 964. The word loss indicates that that is a negative number. Okay? So they lost $964. That just means they need to sell some more refrigerators, man. You know, they haven't sold enough yet. What is the profit when 32 refrigerators are sold? So you put 32 in there. $7,424. Is that what you got? Or did maybe I punched it in wrong? I could make a mistake. 32. Let me do that again. It's negative. Help me out. 32 squared. All right. Then what do I got? Plus 520 times 32. Am I punching this in right? Minus 10,000. Did I punch that in right? Sorry, 5616? Well, excuse my mistake. Good deal? Last question. That's the one that's going to stump us. How many refrigerators must be sold to break even on this product? First of all, tell me what that means to you. If you break even, how much was your profit if you break even? $0. But that means you got to put 0 in for P, baby. All right, here's our equation. We got to put 0 in for P. What you could do is you could try to factor this if you wanted to. You could try to complete the square. You could try the quadratic formula, or you could punch this in your graphing calculator and let it do all the work for you. What would you like to do? I think you want to punch that in. If you do the quadratic formula, that'll work also, but help me out because it's all covered up. It's negative x squared plus 520x minus 10,000. Is that right? Yep. The worst part about this, though, is you got to find the right window because you can't calculate things if they're not in the window. So let's see if we can figure this out. Didn't we have a loss at 18 refrigerators and we had a profit at 32 refrigerators, correct? So somewhere between 18 and 32 on the x-axis is where it will cross it because we had a negative number here, we had a positive number here. So if I go to my window, my x-axis has to go probably up to, let's just go to 32, right? You know at 32 you had a profit, correct? And at 18 you had a loss. I don't really care about how high it goes because we don't care about finding the max. We care about finding the x-intercept. So let's just graph this guy and see what it looks like. Can I see where that puppy crosses the x-axis at? Let's calculate the x-intercept. Second, calculate option 2. I need to go left bound, so I got to find my cursor. Got negative 9. How do you find your cursor? A lot of people are like, I don't know where my cursor's at. Look at where your x value is right here. My x value of my cursor is at negative 8. So I need to get it way over here, so I need to move to the right. And it'll start to show up here eventually. My cursor was in the 8 region. Where you at, buddy? Okay, it's not showing up. What's going wrong? I have found my cursor. I need to go to the left of it. So I am to the left of it. I'll hit enter. I need to go to the right of it. I will hit enter and calculate. 20, 0. Do you think that was factorable? Yes or no?